So we're going to continue with the Pythagoras' theorem. And the Pythagoras' theorem, or also known as the Pythagorean theorem, states that the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides in a right angle triangle. Now, the first condition to be satisfied here is that the triangle has to be a right angle triangle. And how do we know or denote a right angle triangle? We denote the right angle triangle by this little box here. So once you see that box, we know that automatically it is a right angle triangle. Let's say we label and also the hypotenuse, which is the longest side in a right angle triangle, is always opposite to the box, that particular box, or the sign which determines or denotes the right angle triangle. So let's say this triangle is A, B, C. This is triangle ABC. Now AC would be a hypotenuse. Okay, so based on what is said, based on the Pythagoras' theorem, the square of the length of the hypotenuse, so that is AC, and AC to be squared, is equal to the sum of the squares of the lengths of the other two sides in the right angle triangle. So the other two sides would be AB to be squared plus BC to be squared. So if I just remove the brackets, you'll get that AC squared is equal to AB squared plus BC squared. And if you want to find AC, we take the square root. So the square root of AC squared is AC. And that will be equal to AB squared plus BC squared. So that is how we use Pythagoras' theorem to find the length of the hypotenuse. So let's now look at an example of how we find the length of the hypotenuse. So the question states that in triangle PQR, angle R is 90 degrees, and we see that in the diagram. Angle R is 90 degrees here. PR is equal to 7 centimeters, and QR is 6 centimeters. Find PQ. And again, PQ is the hypotenuse. So we could state using Pythagoras' theorem that PQ squared is equal to the sum of the square of the other two sides. So that's the sum of PR squared plus RQ squared. So we can say PQ is equal to the square root of PR squared plus RQ squared. And PR is 7 centimeters, so that's 7 squared, plus QR or RQ is 6 squared. And that will give us the square root now of 49 plus 36, which is equal to the square root of 85 centimeters. And it could be given, and when you're punching that into a calculator, you're going to get approximately 9.22 centimeters. And this is correct to 3 significant figures. Let's look at another example. They ask us to find the length of MN. And so we have a triangle LMN with angle L being 90 degrees. And MN, based on the Pythagoras' theorem, will be a hypotenuse. So, based on the theorem, MN squared is equal to, we could say, NL to be squared plus LM to be squared. So, MN is equal to the square root of NL squared plus LM squared. And that's going to be equal to the square root of 12 squared plus 16 squared. And if we use our calculator, so it is 12 squared plus 16 squared, and that would give us 400. So it's the square root of 400. And that will give us 20 centimeters squared. So 20 centimeters. So whenever you're doing a question on Pythagoras' theorem, or even trigonometry, every time you do a question, you should always have a diagram available. And then show all your working to get your answer. So at this point in time, I would ask you to complete exercise 9C. Questions. Exercise 9C, and I will ask you just to do the odd numbers. Even numbers. We're going to do even numbers. And in some of the questions, you will have to draw a diagram. And